Question today is, are we conductivity cursed? And I say that because I'm measuring conductivity, and the problem we're facing with our internal conductivity instrument that we built is that it's reading 0 all the time. So what I've gotten is this Thermo Instruments advanced conductivity meter. And you can see right now it's reading 0. I do not have the probe plugged in. So here's the probe and some water. This is water with essentially 0 conductivity. It's quite pure water. But not only do I have that, but I have this set. Now, conductivity is an inverse of resistance, so it would stand to reason if you put a resistance across the input terminals of the conductivity meter, it's going to be able to tell you what the conductivity is of that resistor. And these are not just any old conductivity standards, but they are NIST traceable standards. And look at that, serial number 376. They've made 376 of those. For what it's worth, for those who love these numbers, I also have serial number 420 of another calibration kit. But this one, for whatever reason, I decided one day a long time ago I would determine what's inside there. So I would have to say that's probably not going to be exciting to anybody anymore. Just a window into my personality. So here is the conductivity calibration kit. Here's the meter. The idea, of course, is you take one of these calibration standards and you plug it into the back of the meter, and it does two things. It adds a temperature resistor to pretend to show a temperature, and then it also adds a high precision resistance to show conductance. And you can see from the label, this resistor worked out to be 100.01 ohms, which the inverse ends up being, works out to 9.990 millisiemens. This is with a 1 square centimeter area for the conductivity plate, the theoretical plate of the two plates that are put into the water, and they're supposed to be 1 square centimeter plates, and they are 1 centimeter apart. So that's the way these probes are calibrated, to be a millisiemens per centimeter. So, or microsiemens or whatever, siemens per centimeter. So let's plug this in here. Now remember, the issue with the device that we've put together is that everything reads 0. So let's get started here, and wait a second, this reads 0. All right, maybe that one's defective, so let's get another one out here, and we'll pull this one off, and we'll plug in this other one. I need to line up the little slot. Wait a minute, that reads 0 too. Could it be that every one of these reads 0? It's not looking so good, is it? Well, what if we had configured the meter in some way, in some crazy way that's not correct? Maybe we should try factory defaulting the meter. Set its little settings here with its bright red scarlet display with a bezel that you can see through. When I was a kid, I thought the word was bezel, not bezel, but bezel. Bezel, oh, we got a number for a little bit. What was that all about? Should we try putting that other one back in again? Let's put this one in first. Oh, you get a number. Something happened. Let's put this one back in and just see what happens. Not much. Is it to do with, maybe it's to do with bumping it around. Loose connection or something? I don't know. All right, well, as I said, let's try factory defaulting it. I happen to know that if you press the, I think it's the yes, is it the cal button or the yes button? See, here's where the manual comes in handy. Let's take a look. Meter reset is page 22. So we have two things we can do. One is we have a plug it in and press the cal key while the software revision is displayed. So there's the software revision. There's cal defs for defaults. It'll give us a ESC automatically and then go into measure mode. All right, there's measure mode. Let's plug one in. Whole lot of nothing. What about factory self-diagnosis checkout? That's always a bit of a farce, right? How do you know that you're broken if you're broken? So let's try that. That is press and hold the yes key while powering up the meter. Disconnect the cell, otherwise it'll fail test 3. So here we go, powered, yes. We have to do it. Oh, that works. So test 1, it's running test 1. In 7, we've got to go through and go bleep, 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 bleep. Let's see what happens. It came back to the display we're used to seeing at this point. Now we'll plug it in. Well, that's not good. I wonder if we need to figure out what might be wrong with this thing. It gives us some practice at least as to what's wrong with, oops, what's wrong with the connectivity on our internal design instrument. All right, well, let's take a look. All right, so on the back of this thing, we have some screws. Ooh, they feel like they go into threaded inserts, no less. I don't know what this thing cost new, but I'm sure it wasn't $18. The Thermo Corporation tends to have a high opinion of their stuff, and it's made in the US of A. This is I don't even think it has a model. Oh, it does. It's a 162A, I believe, is what this is called. Probably written on the front, but they didn't really put that on the back. They just put a serial number. 17586. 17586. All right, and it looks like it has some metal in there to make it heavy. So you know you're getting value. Oh my gosh, that is quite a lot of metal. So you know you're getting value for your money. That's a heavy, there's a thick plate in there. That's got to be 3 millimeters thick. That's got some weight to it. All right, well, we'll put the screws aside. Let us see what we see inside here. It looks very 90s. The connector for this is a flat flex. Could that just be that that's got some corrosione in it? There's the firmware. 162A. A happy dog in the room. Yeah, that's that. A lot of passives in here. So I can't really see what that one is. But I do see an analog devices. I'm going to guess there's quite an A to D in there. Here's a benchmark battery. That'll be a battery to keep some settings. Who knows where that is in terms of its ability to keep settings. I've got the buttons here. I can feel the buttons. They all work. Yeah, I can't really read the markings on this IC without a flashlight, so I'm going to have to get a flashlight to read that. We got a bypass capacitor that someone forgot, or some sort of what looks like a bypass capacitor. That's the bodge of the day. Does this come out right now? I think it does. Ooh, that heatsink's got some heat coming out of it. I can't really tell what voltage that's supposed to run. It looks like an adjustable. Those are some nice LEDs in there. Sphinx? I can't really tell who the manufacturer is. Yeah, those are nice. This says Orion Research It doesn't really have a date on it, or just Orion research. So this is before Thermo Orion, before Thermo acquired Orion, it looks like. We've also got these pins in here, which look pretty good. They don't look damaged at all, that's for sure. All right, and then we've got some other jacks up here. One of these is for recording. I don't know what that is. And the other one is, I think, to record a reading. The other one is temperature control. And then there's a BNC reference. And there's the ubiquitous 90s serial port there. That is not a place where you get cereal. That kill me. Yeah. Yeah, I mean, that's warm, but it's not killer hot, so it's dissipating some heat, some energy. This stuff's all not populated. That's an option that wasn't present. So let's try, let's just try putting one of these doodlies in there now and see what we get. See if, well, now that I press that in and move that around a bit. Be cool if it read. Look at that. Would you look at that? It was just pressing in that connector. This guy right here. Okay. Well, it isn't hard to put back together, so I think it's the smartest thing is to put this back together and then test it out, because there's only 4 screws. So, 4 screws and a spade connector to ground the inside. So let's plug this spade connector in right here, all without shorting it out. Can we do it? Hold the camera. There we go. It is heavy, that little add-on part. 4 screws. Fortunately, they're all the same length. That's a plus. Yeah, it looks like it was just that connector. Well, that would be really cool. How would self-test know that? I suppose you could have designed that flat flex board so the outer left and outer right connector were jumpered together. That flat flex cable, you could have jumpered together that outer left and outer right cable. And then you would, oh, they aren't the same screws. I think these are too long. Then you would, when you start up, you would have to dedicate a channel to it, but you would test to see if you had connectivity between those two, and if the cable was out, that would tell you that the cable was removed. Certainly you could have done that if that's something that was important to you, to really self-test the system from top to bottom. The unfortunate part too is that that would be a thing that A, could fall out, and B, in assembly or some sort of maintenance, you could decide not to put that in. When I say decide, I mean forget. I decide to forget quite often, so yeah. It seems like the never-ending screw. I'm not going to worry about that. I'm just going to get these 2 in. We'll figure that out in a sec. So otherwise, this makes for some bad viewing. All right, let's see if this thing works. No, I had the power cord was loose, so let's try this again. 4.64 is what this was reading, I think. 4.64, so 4.66 microsiemens. It's supposed to read 10 microsiemens. Well, that's not very good. What's this one supposed to read? basically 100, 99.9730 micro. It's definitely off. So can we calibrate this? Maybe that battery is dead. All right, let's take a look at that. Well, it turns out we can calibrate it with this here cal button. So cal manual, and we need this to read 99.9730. So let's do it. It's a long way off. Oops, there's an acceleration in here. Oh, see, these are terrible. They go faster, 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 so you never really know when they're going to kick in. So I'd argue that if statistically, if you monitored someone doing this, I bet it would take them just as long to do this fast, slow thing and overshoot it than it would just to not have the acceleration. 99.9730. Yeah, that's correct. Press the yes to accept. And it should show back to measuring mode. 99.9730. Now this is showing 99.977, and we really needed it to be 7.3. I don't know that we're going to get there. Nope. Okay, so let's try another one now. You're probably like, I can already read it. Well, I can't. 1,000 microsiemens. All right. And this one should be 99 millisiemens, 99.93 millisiemens. Still says micro. Ooh, it switched. Can we cal that to 99.93? No. Okay, well, let's see what our water looks like since we're already 17 minutes into this. All right, so we'll take this out and we'll take our probe. This is the probe in the water. Plug this one in. This is great that we got this fixed. It's a two-handed operation. All right, 344 microsiemens. Let's switch that around in there a bit. Get the air bubbles off the probe. 339. Now, I'll give you a guess as to what's right here. Just a pinch is all it takes. Drop that in. Look at that. Look at the difference. That's quite amazing. So now we're up to 3 millisiemens. So let's go grab another pinch. 3.6 millisiemens. Very scientific. I just put a pinch in there. All right, so now we're at 13 millisiemens or more. Let's go up higher. Here's more than a pinch. It's probably about half a gram I just put in there. A total of a gram. Half a liter of water. Yeah, about half a liter. 20 millisiemens. Yeah, we're at about half a liter right here. 600 mils. 20. Oh, why not? Let's just go bigger. We're making this water very conductive. It's raining. And it's 20 degrees C, so it's a little colder than standard. But this compensates. The TC up here says that there's a temperature sensor in the probe, and it compensates for the conductivity for the temperature of the solution. So 41 millisiemens at 19.4 degrees C. Not bad, not bad at all. Okay, well, I hope you enjoyed watching this. We did solve the problem with the advanced conductivity Orion 162A, and we're good to go. We've measured some quite pure water all the way up to some salty water. Thanks for watching. If you like it, of course, hit the like button. If you want to subscribe, I'd love that too. That helps me out quite a bit. And if you have ideas for more videos, please do share them. Thank you for watching.